Transrectal ultrasound-guided systematic prostate biopsy, infused MRI truss-targeted biopsy both rely on 2D truss imaging. We propose a novel visualized prostate biopsy system with a true, real-time 3D visualization of a tract-moving prostate, including locations in the prostate that need to be biopsied, a tract truss probe, and a tract biopsy gun. A 3D visualization is easier to use and more accurate because it removes the mental load of performing mental rotations and inferring 3D geometry and relationships from 2D cross-sections, which is what an ultrasound image is. The vPBx is a retrofit on an unmodified ultrasound machine. The vPBx is demonstrated here in a prostate biopsy simulator. The urologist first traces the outline of the prostate in an ultrasound image in at least 5 sagittal and transverse planes. He can also trace the urethra and any ROIs if visible. vPBx uses the traces to build a 3D prostate and a systematic template is applied. Using the visualization, the urologist steers the biopsy device needle to a template location. The yellow core and red disc show where the core and needle tip will be once fired, allowing the urologist to keep the entire needle inside the prostate while sampling each template location and evenly distribute the biopsy cores. The template deviation, which is the mean distance between the cores and their intended template locations, can be minimized. vPBx also allows ROIs from MRI scans to be imported and targeted if they are available. vPBx is compatible with transperineal biopsy in addition to side-fire and end-fire transrectal biopsy. We compared 43 urology residents and 5 non-clinicians performing a 12-core systematic prostate biopsy using traditional truss and vPBx in our prostate biopsy simulator. There is a significant decrease in mean template deviation in the percentage of false negatives of a spherical apex lesion when using the vPBx compared to traditional truss-guided SPBx. Here is the performance of 13 of the urology residents chosen at random using traditional truss to perform a 12-core systematic prostate biopsy on our simulator. The biopsy core sets often cluster together, leaving a lot of unsampled tissue. They often miss the 0.5 mm spherical apex lesions, which the residents could not see in ultrasound. Here is the performance of the same 13 urology residents using vPBx to perform the same 12-core systematic prostate biopsy. The biopsy core sets are distributed more evenly, and none of these sets miss the 0.5 mm spherical apex lesions.